Our next speaker is Jose Gomez-Marquez, director of the Little Devices Lab. Jose Gomez-Marquez directs medical technology design at Little Devices at MIT and is the creator of MIT's first course on affordable medical hardware. He is the co-inventor of the MediKit platform, a series of design building blocks that empower doctors and nurses in developing countries to invent their own medical technologies. Please welcome Jose Gomez-Marquez. His presentation is Creating Environments to Promote Stealth Making in Health.
Good morning. Thank you for having me. Everybody see the slides? There we go. Great. So I work in medical technology, and what we do at our lab is we mash up what normally is seen as DIY and the healthcare world. And when I tell people that, one of the first things they do is say, wait a minute, why would you ever want to do that? Well, what we've seen is a community of makers that have full permission to make drones, to make robots, to send things into outer space. And we have a community of healthcare workers that are creative. But when we try to bring them together, the traditional medical industrial complex, which is the group essentially responsible for filling the materials and equipment in places like this room, which is a typical Boston hospital, says, no, this is not something that you should do. And we through our travels and through our work, what we found out is that actually is quite the opposite, not just from a democratization of medical technology point of view, but also how we actually got here in medical technology. So this is what it looks like in Boston. And if you travel overseas to a developing world hospital, it looks a little sparser, and they still have some machines. And what the WHO tells us is that 90% of the medical technology that it ends up in developing countries is actually donated. And so I'm sure we've all seen the stories on the newspaper where, the church or the Rotary Club or the school donates the used medical equipment, sends them over there, everybody takes a picture in front of the hospital, makes it to the neighborhood newspaper. What rarely gets reported is that 80 to 60% of those medical devices that are donated fail within 6 months. And they fail because they really weren't designed to operate in these environments, and they were rarely designed with the people that are going to use them. And what that looks like is this. So this is a picture of the backyard of one of the hospitals in Nicaragua where we started to work a few years ago. And it's essentially filled with all those good stories and good intentions of well-meaning engineers and donors. But ultimately, the technology just couldn't keep up with the rigors of the field. Traditionally, what we do, when we started to do this, we were, there were a few labs around the country that designed for these environments, and now there's a lot of labs, which is fantastic. One of the things that I found that was very humbling is that as engineers and designers, we were going to go out there and save the day. We were going to fly down, we were going to design these things better, and what we found was that they were already doing it on their own. And we started to then think about, okay, if they're already solving it on their own, can we actually think about a study? Can we look at the research of what makes them tick? And so I had this big idea of I was going to go find these MacGyver doctors, or in a more formal academic setting, what Eric von Hippel at the Sloan School calls lead users. And essentially, these are people that take matters into their own hands. And so I did this study. It was actually my first study, my first job at MIT. I was really proud I had all this structure, and I had this survey to go find these MacGyver doctors. And when I finished the study, over the course of 4 weeks, we realized we got nothing. We got, I met 2 guys. That's it. And then we started to look around the hospital, and we started to notice that there were all these artifacts that were just there, and fixes and small little things that had been essentially DIY'd. And they weren't matching up to what our survey was saying, and certainly none of the doctors would claim ownership over it. And what we found out is that it was actually not the doctors that were making and solving these things and essentially counteracting this effect. It was actually the nurses. It was nurses like Daniela Urbina, whose stethoscope broke. And basically what she did is she took a little piece of plastic and she started to experiment with different pieces of plastic, cutting them in circles and then replacing them to see which one would actually vibrate at the right frequency to transmit the heart sounds. And she ended up settling on overhead transparency slides. And you can kind of see the red Sharpie markers of whatever was still, being taught on that Saturday seminar that then she just, recycled and took. And what struck me is that she wasn't one of these folks that she had the idea, and then she immediately went over to show it off. It took me 3 hours for her to not only tell me the story of how she made it, but at the end, she was embarrassed to show me her device. And I thought that was terrible because at MIT, we would have given her a room like this to basically show her hack. And we started to notice this pattern. And I fell in love with this notion of stealth innovation that's out there in the healthcare system, but for large reasons, this informal type of problem solving is just not coming up into the surface. And then we started to spot a pattern, and we started to see more of it. People like Melania, who basically would cut hand bandage goggles for little kids under phototherapy because they couldn't afford it. And then we would actually say, okay, why don't we make devices so that they can actually solve on their own, but run with them instead of us providing a solution. So we introduced them to things like foot-powered nebulizers that were simple technologies that work just as well as the ones that you would buy for $80 in America. And then what happened is that those nurses, those hacker nurses, started to teach the doctors. And the dynamics became incredibly creative because it wasn't so much the traditional doctor comes in the room and sucks the oxygen out of the air and all the nurses shut up. Now the nurses were actually not empowered and proud to show the doctors how to solve and take care of their patients. And this is not just the story of the developing world. The reality is that making in health, the notion of DIY in healthcare technology has been with us before and has really changed the way we do medicine. Charles Dotter in 1930s used guitar string wires and Volkswagen brake cables to make interventional radiology devices. Many of you may have heard of the balloon angioplasty. Well, that's Andreas Grunzig's kitchen table in Switzerland, and he basically hacked the first prototype, and you can see the pizza magnets in the back of the kitchen, and got permission from his hospital to try it on a patient that ultimately was otherwise going to die, and then came to America and changed the way we treat heart disease, starting at Emory University. A lot of people have heard about Medtronic. Well, the founder of Medtronic started in his garage, making the first wearable pacemaker. And recently, I learned about Margaret Crane's invention in 1969, where she was a graphic designer working at a chemical company, took a paperclip holder, and essentially convinced the chemist that a home pregnancy test was a good idea. But it was her design. And essentially changed the way women manage family planning. Today, that continues to be alive. We have examples like the Night Scout project, a group of parents. So it was an IT specialist at Wegmans, which is a supermarket chain in New York. And his son had type 1 diabetes and got prescribed a continuous glucose meter. Well, it turns out that the glucose meter had a wireless signal that you could basically monitor, just like this microphone, from here to the end of the room. But when the little kid went to kindergarten, he had no idea what was his glucose levels. So knowing a little bit about IT, knowing a little bit about hardware, over Twitter and over a Facebook group, he collaborated with other families around the country, hacked the wireless signals coming out of the device, patched it up to an Android phone, and then eventually was able to reach those signals through a wearable watch. But then he did something that I think is the more interesting part of the story, beyond the hardware hacking. He put all the instructions on Facebook, and 2,000 families around the world replicated his exact same hack. And they formed this notion, this project called the Night Scout project. They took it to the FDA, and they said, okay, we want, what do we do now? And the FDA said, well, we need to know who the officer of the company is so that we can think about what regulatory steps you need to say. And they were like, we have a Facebook group. And the FDA basically said, we can't do anything with you. We can't stop you. We can't promote you. We can't. And so it's one of these things where the technology becomes so democratized that now healthcare is no longer one of those barriers that makers can't enter. So inspired by our work in Nicaragua, the Robert Wood Johnson Foundation called us, and we started together this project called Maker Nurse. And the question was, we like what you did in Nicaragua. Are there nurses in America that do this type of work? And could you promote it? Could you understand it? And so we started to look at it, and we looked at the history. And the reality is, there were tons of examples of nurses doing this type of work historical. Whereas, this is an evacuation coach for babies made by a nurse in North Carolina. They would make colored IV tubing so that you couldn't confuse which IVs to use. They would make syringe holders and sterilization organizers and all sorts of medical devices. They even had textbooks called the Design and Operation of Improvised Medical Equipment for Patient Care. And it was a widely accepted approach. So we looked at the history, we did bibliometric analysis, and we started to notice trends. At the beginning of the century, this was called improvising. And then over the world wars and in mid-century, it became practical suggestions. They actually had essentially their own make magazine called the Trading Post. And then something interesting happened. I know you see a little blip in the 70s. Well, if you look at the late 50s, there's all of a sudden drop again. And what we're still researching it, but one of the things that we found is that's when nurses got introduced into the notion of what is now known as nursing research. Essentially, somebody at the top told them, you shouldn't be doing that. That's not what adult nurses do. You need to do this other, more scientific stuff. And so our question at Maker Nurse was, okay, did it stop? Or did it go underground, just like Daniela had to operate underground? And then we tried to understand what was this other blip in the 1970s. Well, that was actually called the Creative Care Unit, following something called Ideas That Work. And when we looked at those two themes and we started to look at the technologies that were being published in those journals, they were quite frankly boring. It was things that you knew were going to work. Like how to put labels on sheets so that you know how to identify the patient. My gosh, that has nothing to do with how to make a ventilator out of an umbrella that was being published in 1920s. So the creativity really went down. And so our job was to go and find them. And so we did. We basically went all over the country. I went to places I could never dream of going, like Pikeville, Kentucky, and Galveston, Texas, and Corpus Christi, and the very deep Orthodox communities of Brooklyn. And so I ended up this is a picture of Maimonides Hospital. And these are examples of just everyday hacks. This is a nurse in Colombia, actually, that was showing us how to replace trach tube materials. This is a nurse in Brooklyn, and he does Lego models so that little kids that have to go under an MRI that are autistic don't freak out. And so he basically remade the Saturn V Lego kit into an MRI model. And it's reduced sedation percentages by a significant amount, which is a huge issue with pediatric patients. Roxana Reyna at Driscoll Children's Hospital made this series of bandages that avoids a very invasive operation for a condition called an omphalocele, which is when your intestines are born outside of your body. It's totally solvable, but this reduced operation costs by pretty much $1 million a year for that hospital. And she got to meet President Obama a couple of years ago at the White House Maker Faire. So we took all this information, we started to make a prototyping genome, and try to understand, okay, so if makers use Arduinos and 3D printers and these other things, what do nurses use? And so we have now a library of all these materials, And then we can make a complementary library to think, okay, what would Roxana use a Raspberry Pi for? What if we introduced her to Sugru so that she doesn't have to use a $12 Foley catheter as a zip tie? And this allows us to dial back against this notion that all fancy technology needs to be magic. I love this quote by Arthur C. Clarke. But the problem with magic is that it's black box. And when you go to a medical visit, you'll see a lot of black box because they kind of happen to be white or aqua or beige, but you don't really know how these devices work when you visit a doctor. And that is actually by design. And we want to basically push back against that so that more nurses and more doctors can make stuff and have the materials to do so. One of the things that we did after we were done with the Maker Nurse projects, we spun off a company called Maker Health. And what that does is we install maker spaces inside hospitals so that nurses and doctors don't have to call MIT or engineering schools and say, can you solve this for us? But instead, we give them the tools so that they can solve it for themselves. So when we do get the call, we're collaborating at a much more equal level, and then we get to solve hard problems. We make construction kits so that people don't have to necessarily navigate a whole set of educational materials or facilities, because construction kits lower the barriers to entry. So these are construction kits for diagnostics, for tracking orthotic devices, for sensorized inhalers, for adherence, and they're all over. And one of the things that I think we're most proud of is that the most innovative nurses that we have found are not just, in fact, they're not so much in what we would call brand name institutions that we're used to here in Boston. They're, frankly, in those, I kind of describe them, they're not in the cool Indiana Jones territories of places like Nicaragua. They're kind of like in those drive-by hospitals that you just go by the highway and don't even think twice. But that's where babies are born and hips get replaced. And so they're driven, frankly, by just taking care of their patient. And that's what's really keeps the Maker Nurse movement going. We teach this at MIT. We try to embed this notion of unblack box to students so that they don't design more black boxes, but that they design construction kits that other people can hack. And I'll close with this, because I think that we need more of these types of daring nurses. We just need to stop getting them from staying stealth, but maybe promoting tools so that they thrive in their stealth environment, so that we can democratize experimentation in medical technology and we can try more things, even when they don't work the first time. Thank you.
It's come to my attention that some of you are not tweeting your questions but may have them, so please do. Even while I'm speaking, I'd prefer to be saying your questions. So I have one from Twitter. Is gender a factor in whether people see themselves as hackers and whether others take those hacks seriously?
I don't think so. I know it's especially in nursing, it's easy to assume that that there's more women nurses and doctors than male nurses, but we have seen some fantastic examples from both. So I don't think our data doesn't say that. I will say that I would say 90% of the students that I teach at MIT are women, and they make some fantastic prototypes.
In this country, hacking is celebrated, praised. You're like, great if you can hack. I go online all the time to say, how can I get around X, Y, and Z? I was just wondering, in other countries, you said people were shy to speak to you about innovations they've made, as somehow it's thought not to be celebrated, not to be such a good thing?
Yeah, so this is something we think, it is still celebrated in the same way that, you jerry-rig something very quickly. But because one of the things I tell our students when we go to other countries is, please don't wear your MIT shirts, because you're just going to intimidate the hell out of people. So the last thing they're going to do is show you their little jerry-rigged thing. So I think it's accepted, and different countries have taken different, even national initiatives. Cuba is an excellent example of that. But at the same time, the people at the top don't want to admit it because it shows a weakness of institutional progress, which is a shame.
It just shows that, to me, it just shows that you
That
didn't
the-
have the appropriate thing, not that it was
I think
institutions. Yeah.
right, it shows that the people are going to just make things work, and they're super creative, and at the end of the day, that's the biggest asset, not whatever 3D printer you can afford.
That's a devastating picture of all of that donated equipment. How understood is that? Because I didn't know that, that this kind of donations are not useful, and that there can be useful in a different way.
I think it's misunderstood a lot because everybody, especially in global health, because it's public health, they focus too much on the delivery and scaling of it. They assume that the universities or the companies of the world have a bunch of products on the shelf that just work, and then the biggest thing is how do we get them out there? And that's just not true. The reality is that demonstrates a lack of the R&D investment required to actually make the products for those countries, and for countries, and for environments here in America too. One of the biggest things that we're looking at is how do we bridge what I call the digital health divide? Because even though you might not be able to afford it in Nicaragua, well, I know a lot of neighborhoods in Boston that can't afford a lot of these medical technologies, and we're not making them any more affordable. It's not a driver.
It seems to me, and this could be just my little hobby horse, that there's a layer of arrogance going on in wherever you are that assumes that the MIT, the best thing, the not small thing, or whatever you have to say person that works every day can't be the solution to the issue. How do you deal with that, getting past that to get to folks who really have some great ideas about what works for them?
Sorry, meaning?
It seems to me like a layer of arrogance about what should work, what you should accept as good, what we know, what you don't know, little person, big person kind of situation.
Absolutely. So in medical technology, what we've seen is actually a deeper level of, I think it's engineered fear. So it is the only industry that has thrived by keeping people away from participating in the process with the excuse that you'll get hurt. Not even the gun industry prohibits gun owners from modifying their shotguns. The reality is that, they do the whole it is a thing. And in medical technology, even though we have countless examples that prove the opposite, there's this whole I think there's a guild issue where over time biomedical engineering became a guild, and in order to protect it, I think subconsciously engineers basically, we've had students from other universities, they'll come up with us and say, when we tell them what we do, the first thing, but you can tell it's already programmed in them, there's like, yeah, you shouldn't be doing that. And I think over time it's just going to be, that's going to slow down by attrition, because just like the Night Scout project showed us, you can't really stop it. What I didn't mention is that device forced the company that made it to accelerate their product by 6 years.
Wow.
And they bought a company 5 years ago that did the exact same thing that the Wegmans father did, and they basically had to write off that investment.
Just checking, make sure I don't have another. Okay. So you mentioned just in passing some of the cost savings, and now we're at a space where health costs are incredible.
Yeah.
Can you speak to, if you could project or extrapolate out, so if more of this kind of stealth making in health was at play, how much could potentially be saved?
I'll give you, I can't, that's such a, I need an Excel sheet, basically. But I'll just give you a couple of examples, okay? Digital health alone. If you compare digital thermometers that you buy at CVS, $5, $2 on Amazon. Now, there's all this talk about taking electronic medical records, integrating the health data of the patient, and then having that hardware, the Internet of Things, having all that hardware talk to medical records. Well, when you look at the machines now that can actually take, essentially you take an inhaler, you put an antenna on it, and then it transmits data. Well, that inhaler goes from $10 to $50. That thermometer goes from $2 to $35. The pill bottle goes from, $2 of a pill bottle to a $300, I've seen even $800 electronic pill bottles. So my grandmother is probably on like 6 medications. So the notion that our family is going to, cough up $2,700 to do that these are very large amounts of money. And what I want to do is just show that anybody can do these things. And it doesn't have to be a balloon angioplasty device, but if we just start with digital health, we can save the system a lot of money and debunk a lot of these notions that these are magical technologies.
Finally, this is just kind of a personal question. What is the role of someone who can make nothing, but who can complain and figure out what needs to be made, but nobody's listening? I could say, listen, we need somebody to figure out how to do X and Y. Seems to me there must be people at every place that can tell you what's not working. They may not be able to make it, though.
That's okay. I think that the first step that they can do, and that will be incredibly enlightening, is just take it apart. Take a picture of it. If we had taken the EpiPen apart in 1985, and a bunch of moms would have said, "How is this different than a Nerf gun?" You take apart a Nerf gun and take apart an EpiPen. We would have not gotten to a $650 EpiPen price. That doesn't mean that they have to engineer it, but being more educated about the process of what's there. Just like we treat iPhones, right? Everybody, I don't know how to make an iPhone, but I kind of know that camera's kind of crappier compared to the other one. So just being educated about that and not being passive, huge, huge.
All right, well, thank you.
Thank you so much.
Jose Gomez-Marquez, Stealth Making and Health.